The history of science is marked by a relentless pursuit of understanding the natural world. Along the way, scientists have formulated laws and theories that have provided the foundation for our understanding of reality. However, the process of scientific discovery is far from linear, and some of the most famous scientific laws that were once considered unassailable have been proven wrong, reshaping our understanding of the universe. In this video, we delve into some of these instances where long-held scientific laws were challenged and ultimately debunked. Number 10. Newton's Law of Universal Gravitation. Sir Isaac Newton's Law of Universal Gravitation, formulated in the 17th century, was a cornerstone of physics for centuries. This law stated that every point mass in the universe attracts every other point mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. However, the advent of Albert Einstein's theory of general relativity in the early 20th century fundamentally changed our understanding of gravity. Einstein's theory proposed that gravity is not a force exerted at a distance, but rather a curvature of spacetime caused by mass and energy. This led to a more accurate prediction of gravitational effects in extreme conditions, such as around massive objects like black holes, where Newton's law breaks down. While Newton's law of universal gravitation is still applicable in many everyday scenarios, it was proven wrong in the realm of extremely strong gravitational fields and high-speed motion. Number 9. The Geocentric Model. For centuries, the geocentric model dominated human understanding of the cosmos. This model, championed by ancient thinkers like Ptolemy, placed the Earth at the center of the universe and suggested that the sun, planets, and stars revolved around it. The Copernican revolution, spearheaded by Nicolaus Copernicus in the 16th century, challenged this geocentric view. Copernicus proposed a heliocentric model wherein the sun stood at the center of the solar system and the planets, including Earth, orbited around it. This shift in perspective eventually laid the groundwork for our modern understanding of the solar system and the universe. While the geocentric model was once a cornerstone of astronomy, it was proven wrong by observations and calculations that better explain the motions of celestial bodies. Number 8. The Luminiferous Ether. In the 19th century, the concept of the luminiferous ether was widely accepted in the scientific community. This hypothetical medium was thought to permeate all of space and serve as the medium through which light waves propagated. However, the famous Michelson-Morley experiment in 1887 aimed to detect the motion of the Earth through this ether, and the results were surprising. The experiment failed to detect any significant difference in the speed of light in different directions, challenging the prevailing notion of ether and leading to the development of Albert Einstein's theory of special relativity. Einstein's theory proposed that the speed of light is constant in all inertial frames of reference, regardless of the observer's motion. This revolutionary idea shattered the notion of a luminiferous ether and revolutionized our understanding of space-time and the nature of light. Number 7. The Phlogiston Theory. The Phlogiston Theory, which originated in the 17th century, attempted to explain combustion and other chemical reactions involving fire. According to this theory, substances that burn contained a hypothetical substance called phlogiston, which was released during combustion. However, the work of Antoine Lavoisier in the late 18th century laid the foundation for modern chemistry and contradicted the phlogiston theory. Lavoisier's experiments demonstrated that combustion involved the combination of materials with oxygen from the air, leading to the formation of oxides. This groundbreaking work led to the discovery of the concept of elements and the development of the modern understanding of chemical reactions. The phlogiston theory was proven wrong by empirical evidence and replaced by a more accurate explanation of combustion and chemical processes. Number 6. Lamarck's theory of inheritance of acquired characteristics. Jean-Baptiste Lamarck proposed a theory of evolution in the early 19th century that suggested organisms could pass on acquired traits to their offspring. According to Lamarck, if an organism used or didn't use a particular body part, those changes would be inherited by its descendants over time. Charles Darwin's theory of natural selection, presented in the mid-19th century, revolutionized the field of biology and challenged Lamarck's ideas. Darwin's theory proposed that species evolved through the process of natural selection, where individuals with advantageous traits were more likely to survive and reproduce, passing on those traits to their offspring. Modern genetics and the discovery of DNA have further solidified the understanding that inheritance is based on genetic material rather than acquired traits. While Lamarck's ideas were influential in sparking discussions about evolution, they were proven wrong by subsequent discoveries in genetics and natural selection. Number 5. The Caloric Theory of Heat. In the 18th century, scientists proposed the caloric theory of heat, which posited that heat was a fluid-like substance called caloric that flowed from hotter bodies to colder ones. This theory attempted to explain the transfer of heat and the expansion of materials when heated. However, as experiments and research advanced, the understanding of heat shifted towards the kinetic theory of heat, which explained heat as the motion of particles. This shift debunked the caloric theory and paved the way for our modern understanding of thermodynamics. Number 4. The steady-state theory of the universe. Before the Big Bang theory gained prominence, the steady-state theory was a competing idea regarding the origin and evolution of the universe. This theory, proposed in the mid-20th century, suggested that the universe had no beginning or end and was constantly creating matter to maintain a steady density. The discovery of cosmic microwave background radiation provided strong evidence in favor of the Big Bang theory, which showed that the universe had a definite starting point and has been expanding since its inception. Number 3. The Ptolemaic model of planetary motion. The Ptolemaic model, developed in ancient times, described the motion of planets in the sky using a complex system of epicycles. This geocentric model placed the Earth at the center and attempted to explain the retrograde motion of planets. However, Nicolaus Copernicus' heliocentric model, which correctly positioned the Sun at the center of the solar system, provided a simpler and more accurate explanation for planetary motion. Copernicus' model eventually supplanted the Ptolemaic model, leading to a revolutionary shift in our understanding of the cosmos. Number 2. The Ether theory of electromagnetism. In the 19th century, the Ether theory was proposed as a medium that filled space and served as the carrier of electromagnetic waves, including light. This theory attempted to explain how light could propagate through a vacuum. However, experiments like the Michelson-Morley experiment mentioned earlier failed to detect the presence of such an ether, paving the way for Albert Einstein's theories of relativity. Einstein's work redefined our understanding of space, time, and the behavior of light without the need for a luminiferous ether. Number 1. Phrenology as a map of the mind. Phrenology, popular in the 19th century, attempted to map a person's mental faculties and personality traits by measuring the bumps and contours of the skull. This practice claimed that specific areas of the brain were responsible for certain traits and characteristics. However, as neuroscience advanced, it became clear that the brain is a far more complex and interconnected organ, with cognitive functions distributed across various regions. Phrenology's oversimplification and lack of empirical evidence led to its discrediting as a legitimate scientific theory. And there you have it, a fascinating exploration of famous scientific laws that were proven wrong. From gravity to the structure of the universe, from heat to the nature of light, these instances remind us that the pursuit of knowledge is an ever-evolving journey. If you enjoyed this video and found these debunked scientific laws as intriguing as we did, don't forget to give us a thumbs up and hit that subscribe button.